I always like to begin by talking about stories, and I don't like the usual introductions of like, can you share your name or and what you do or whatever. I think that a better way to do that and a more interesting way is to really just to hear a story that you might have of how you got into what you're currently doing. And so, how I want to frame that for you is that I want you to dive into the story of how you started getting into computer science and software engineering and how that led you to go to live in Paris.
I actually like that way of starting the interview. How I got started with software engineering. I started pretty early, actually. I think when I was like 13, 14.
Hmm.
Um, so we had a computer science. It wasn't called computer science, but like introduction to computers. And you could code with this language. I don't know if you know it. It's called Scratch. Essentially, you have
Hmm.
like these blocks that you put together, and you end up with sort of program. But it's not really like a programming language.
Is
But
it a like a platform where you have like a orange cat or something like
yeah,
that?
yeah,
Oh
exactly.
yeah, I know it. I know it.
Yeah, so we had a class about that, and I really loved it. I don't know, I just went with it, and really like how you were able to like describe pretty like complex logic with this um these like little blocks. So I ended up really liking it, and a professor of mine like noticed, and she said like um we have like this competition coming up. It's like all of the French schools in the world have this competition, which is called what is it called? Algo Algorea, something like that. Um, so she signed me up, and actually everyone does it. And you have like these levels. We have like these little problems. You have robot. You need to like make it move around. Um, she ended up pushing me. Like I didn't want to do it at first, but she pushed me, and I ended up getting to the finals of this competition. And the finals, you actually had to code, right? You had to use like Python or any other programming language. So I didn't know how to code, and I obviously lost the the finals of this competition, and that's when I really said like, okay, now I want to learn. I want to get into it, and that's how it all started. Losing this competition, but I ended up really liking the uh, yeah, the algorithms you could make with these little blocks.
How did that then lead to your development path to get into to go to Paris to study that for university?
Right. So um, I learned how to code, and then I kind of like left it there. I didn't really code a lot uh, until I actually got to Paris. Um, so I don't know. I kind of like you had COVID that came, and all I did was like play video games. Then I came to Paris because I don't know, it was kind of like the predetermined path that you took when you went to my school. Like a lot of people came to Paris, a lot of my friends. So I came here. I started out at an engineering school, and here in France, you usually start with this like 2 years where you have like a lot of different subjects, like very very uh, um, um, like demanding. So I started with that, and on the very few time that I had left, I learned like different languages, different frameworks, and I did 1 semester of that, and uh, I stopped. Like I didn't like it. It was interesting. Like I got to learn from a lot of different subjects, but I felt like okay, I really like computer science. I really like math, and that's like what 20% of what I actually do. So there was like chemistry, physics, um, which is interesting, but it's not what I wanted to do. So then, yeah, I spent a lot of time learning how to code and actual skills. So I would look on LinkedIn different job postings and would see what skills they were asking for. So I went and learned those skills. Um,
Mm-hmm.
and then yeah, I got a job, an internship at this company called Heeks Technologies, and they work with autonomous vehicles. So it was really hard to get that first internship because I had no experience, uh, had dropped out. So my mother told me, yeah, you either get a job or you have to come back. So, yeah, it was hard. Like I got a lot of no's. I applied pretty much everywhere, and yeah, this company they took a shot at me because I was 18 years old. I knew a bit, but didn't have that much experience, and it ended up being great. I had the chance to work with like scientists, and work with autonomous vehicles, which I think it's one of the most exciting subjects there are in the field of artificial intelligence. So yeah, that's kind of what got me to Paris and why I stayed in Paris. Because if I hadn't found that job, I probably would have gone back to Ecuador.
That's very interesting. This last part of like how you got your first internship makes me think of two episodes that I have recorded. The first one is William's episode, in which we talked about like his story and how he got like what one of the things we talked about was how he got into an internship in I'm not sure what the name of the company was, but an aerospace manufacturer, and that he had like no. I mean, he did have like some knowledge and skills, but he lied on his resume to some extent, and so he had to learn a lot of things for that. And so that's one point. And then the second one is an episode that I recorded with. Actually, he's my cousin. So yeah, with my cousin, one of my cousins who is working on a company called Zoox in California. That episode hasn't been released yet. But yeah, he basically studied mechanical engineering, I think, or mechatronics engineering, and then he was working here in Mexico in fourth, and he went to California to work on that. So that's very interesting. What were some of the things that you needed to learn to get into that? Like some specific technical topics that you needed to learn or to keep developing.
Sorry, it got cut off for a second. Can you repeat that?
Sure, yeah. No. Which were some of the topics that you needed to like learn for that internship, or some topics that you already knew but that you needed like to develop for to get into that?
Right. So Um, essentially, what I knew so far was I could code in Python, and I had developed like a few scripts, but I didn't really know how to code. Um, so what I did was really I went on LinkedIn, I looked up yeah, pretty much every job, and I remember I would take notes on the different like skills they required, and that's how I chose like where to start. So I saw that there was this library for front end development called React,
Mm.
and everyone was looking for that. So I learned React, and um, yeah, kind of like William. I don't think I can say that I lied on my resume, but yeah, you always tend to exaggerate. Like I did one
Mm.
like little course on React, and I say, yeah, I can do React. Um,
Uh-huh.
and same with a few skills. I think I yeah I learned pretty fast, so I knew that yeah, if I have the foundations, then I can learn on the job, and that was what happened really. So what I learned before was yeah React. Learned a bit of Docker, a bit of cloud. Everything that was kind of like sexy at the moment.
Mm.
So yeah, that's what I did.
Mm. You also mentioned that in this first internship, you were doing a lot of things with scientists and engineers, and I guess that you got a lot of experience or also some advice or like insightful knowledge from them. How was that experience of working close to people like that? Who, I mean, you might even have worked with people with a PhD or things like that. But yeah, what was it like working alongside them, and what were some of the things that you learned from them?
Yeah, so I actually learned a lot of things, as you mentioned. A few people were PhDs. I was actually sitting like a couple spaces from one who was like the expert in like these robotics. So for computer vision on vehicles, they use this software called ROS, which essentially allows you to like visualize stuff. And essentially, what I learned is that I didn't want to do a PhD, but I wanted to work with PhDs, right? So there was like these,
Mhm.
they had so much depth in knowledge, and I found that fascinating. But I was more drawn to having more breadth, right? Knowing, a little bit about everything, and then finding what I wanted. So that kind of positioned the rest of my trajectory so far. Like, I see myself more as like a bridge between research and applications. So I don't want to be the guy that spends years in lab, like researching things. No, but I want to like speak to those people that have done a lot of research, that know a lot, and then build stuff like real
Mhm.
applications for the research. And that's kind of like what I started doing a bit over there. Um, so yeah, and I think that's the most important thing that I learned. And I kind of learned. I remember I had this friend who I'm still friends with so far. She told me like, yeah, you need to like take initiative, because if you're just an intern, they will like treat you as an intern, and they will give you like the lowest of the lowest stuff to do. But if you actually go and ask for things and propose things, then um, you'll get them. Like, I actually apply this principle until today. If I go and ask, hey, I want to do this, I think you could do this, then people tend to say yes. And this
Mhm.
applies mostly for startups. If you go at a big company and you say, hey, I want to do this, they'll probably tell you no. Like, they have
Mhm.
like very specific things that need to be done. And the process for making a new project is very complicated. But yeah, I think those are the two most valuable things that I learned. Like, okay, I want to
Mhm.
bring research and applications. I want to work at startups, and yeah, like that's the most important things.
That's great. I like the part of having initiative because I think that's important, especially, and I want to know also your thoughts on this. But like this part of how AI is influencing like people looking for internships or jobs or things like that, how initiative might make a difference in how AI is growing and automating jobs that already exist. So that's one point. But then just another, which is like an extra comment. I am currently developing an app for clients from the US. I just know like basic Python, CSS, HTML, and some Java. But like that's been enough for me to like just uh, with AI like develop the code and do all of the things. And I'm also doing like the project development part of this. But like through this project, he has become like some sort of mentor of mine, and like he has done many things business wise throughout his life. And he like his main company right now is a manufacturer of like an industrial product that helps to like flatten surfaces. And they sell that like to the U.S. Army and to big industries and things like that. But he is just he studied business, I think, so he didn't ever get into science or STEM in any like academic or traditional way. But what he has been sharing with me as a mentor is that like even if you are not like academically into that, you can like professionally get into that by surrounding yourself with people like that. You might not have like as much knowledge or skills like them in some ways, and so you will be limited to some extent, but like you will be able to talk in their language, so to say that, and that is a way for you to like be able to work on projects like this, and that's been like an like a way in which I have been mentally approaching this, like trying to learn basically like the language of these kind of people, so like scientific language, like technical language, and trying to think like them, and also of course like trying to get into the technical stuff to actually learn it. But like since I'm more interested on like the project development part and on the business side of it, I think that that's a good way for me like to balance these two things. And in some way, it sounds like that was kind of your experience because you like stopped the academic path at some points, and then you continued like through work to get into these things, and you were basically getting exposed to these things through conversations and through work and through practice. So yeah, that was just one comment on that. And yeah, if you want to comment anything on that, please do. But yeah, I wanna get into like the other part, which is like well, yeah, no. First, do you have any comments on that?
Yeah, yeah. So I think, well, if what you want is to get into like project management or um, a technically adjacent role where you work with technical people, but you might not have to be technical yourself, I think it always helps to know the technical side. You don't have to be an expert, but the product managers that I've worked with, you can really tell the difference when someone has a technical background and when they don't. And usually, the impact that the ones that have a technical background can have is much greater, I think, because
Mhm.
mm, if if you don't understand the technical side, then you really depend on what other people tell you. But if you at least understand it, you can have a much clearer idea. So yeah, I think that's what I have to say about it. So if you know you don't want to be like an expert programmer, that's sort of you're right. I think you don't need to be right now with the rate at which AI is growing. I think it's much more valuable to actually um, be on the product, on the creative side of things, because the tech side will eventually take care of itself.
No, yeah, for sure. And actually, now that we're getting into AI, what are your thoughts on the other topic on like how initiative can help for getting ahead, even when AI starts taking over the technical things or over tasks that can be automated? What
Right.
are your
So
thoughts on that?
I think that up until now, if you just did the minimum required stuff, you could get along, right? If you were a very bad programmer, or not necessarily bad, but just average, who just did the minimum necessary, you could go have a relatively stable job and have some impact. But I think that right now, if you have like average or below average skills, then you're very likely to get replaced, right? Um, so I have like mixed feelings about that, right? But I think regardless of what I think, it's what we're seeing, right? A lot of tasks are being replaced, and I think that what's really going to set you apart is that initiative, that creativity, and and yeah, how you can leverage these tools in order to have an impact, right? Um, yeah, some phrase that you hear a lot nowadays is, yeah, you won't get replaced necessarily by AI, but by someone who uses AI.
Yeah, surely. And I think that getting back to the other topic of project management and project development, and having that be taken care of by someone who knows the technical side and someone who doesn't. If you are someone who doesn't, like the product management part can be taken care of one of the people in the team who are already like doing the actual technical stuff, but who just uses AI to do the project management side of it. Compared to like someone who is a leader in some way who is essential because he is also a very good advisor, since he is like technical and since he knows like a lot about the actual product and the actual methods that you are using. So that's just like a thought that came to my mind. Do you agree with that?
So I think that there are many ways you can go about this. I've seen companies that they don't have product managers, where their philosophy is just, yeah, the engineers know what needs to be done. And I think that ultimately depends on what you're building. If you're a developer that's building products for developers, I don't think that a non-technical project manager or product manager will add much value.
Mm-hmm.
But if you're building something um, for perhaps yeah, a set of users that you're not yourself a part of, then I think you know, product managers or project managers can have their value. Um, and it ultimately depends on the team. I think that there are teams who work very well without PMs or whatever, and there are teams who don't. So I think that it's ultimately about people, right? Um, so I don't really have a very um, set opinion on that. I think it ultimately depends on the product and on the team.
Mhm. You know, something interesting about this is that you mentioned that you, like after this first internship, you realized that what you wanted to get into was like bridging the very technical and theory driven side of a project, so like the research part. You wanted to bridge that with the actual application. What makes sense with about what makes sense about that, with this last ideas, is that like a product manager or like a leader of a team who is helping to bridge the application of a project
Hello.
for the users, and if the users are not technical, like that's where this comes, right? Like bridging those two things. So in some way you're looking to be that way, right? Like trying to connect those two, the technical side and the non technical side for the actual end users.
I think I lost you for a second there. I just realized I was like downloading some
Oh,
pretty big data set. So let me pause that, and it should be good right now. Yeah, so it's working.
okay, sure.
Yeah, now it should be good. I'm sorry about that. So yeah, essentially you were saying that um, you're asking about my perspective on being the bridge between research and applications.
Mm-hmm.
Is that so? Okay. So
Yep.
I think that's something that um so let me tell you a bit about my background so you can understand. So I did that internship, worked with autonomous vehicles. Then I worked on Big Four consulting internship. It was at Deloitte, and I didn't like it. Uh, I really didn't like it. I learned uh, it was there were some interesting aspects, but I knew I didn't want to work at a company like that. And I worked at a startup that I was the founding engineer of, which is called Ogre. So that startup also kind of mixed the research heavy part. The founder was this like PhD who used to make microchips, so he's like a genius. Um, and then the other company is the one that I mentioned, Hexaly. And I also worked for another startup where I was also founding engineer. Um, which essentially is more like a consumer product, but we heavily use AI and large language models. So I think that
Mm-hmm.
um, regardless of my role, except perhaps at at Deloitte, I've always been at this intersection of, okay, like you have this research and you have this product, right? How can we bridge that? How can we um, take a research paper and actually turn it into something useful, right? And
Mm-hmm.
that's something that has always fascinated me. And that's kind of where I think I want to position myself right now, because I know I don't want to be just a developer, that someone tells me what I
Mm-hmm.
need to do and I just do it. I know I don't want to spend years at a research lab. So I think what I'd like to do is right there in the middle, right? So I'm kind of in
Mm-hmm.
the point where, okay, I don't need to understand um, everything, right? I don't need to have a very deep knowledge about a certain topic. I just need to know enough to understand what people are telling me, and especially so I can like imagine certain use cases, right? So
Mm-hmm.
an example about that, you have this thing Google DeepMind just dropped this
Mm-hmm.
model called Alpha Earth. I don't know if you um,
No, I haven't heard about that one.
it came out yesterday essentially, and it's this like
Mm.
huge model that is able like takes um, a lot of satellite data, weather data, lidar data, and essentially for every 10 by 10 meters of the Earth, it has an embedding. Are you familiar with what embeddings are?
Yes, because I just learned about that in an AI course, I think. But can you refresh that idea? I guess also for people listening that might be useful.
Right, right. So
Like
yeah, without getting in a lot of in the technical aspect, embedding is like a vector. It's just like a series of numbers.
oh
So yeah, it's a vector that conveys a certain meaning, right? So it's very
hmm
used by large language models. So yeah, they use embeddings to kind of understand the meaning of a word, of sentence, right?
hmm
And they essentially did that, what ChatGPT does for words, but for the Earth,
hmm
right? So you have like 10 by 10 meter,
hmm
10 by 10 meters, like pixel on from satellite view, and they're able to take like
hmm
data for an entire year and turn it into an embedding. And what's cool about embeddings is that you can do like similarity searches. You can say, hey, this embedding is very similar to this one. They're similar vectors, so they convey. In the case of large language models, the word conveys a similar meaning, right? Um, and in the case of the Earth, you can see the similarity between perhaps very distant places. I know you have an island in coast of Costa Rica that has a lot of similarity with an island in, I don't know, near coast of Thailand, for example. So you can infer a lot of things about the similarities of weather, of temperature, um, and yeah. So that was like just a parenthesis, and it's very interesting. The work they're doing is amazing, and yeah. So I read the research paper. It's I understand like 70%, which is more than enough to be able to do something. And then, yeah, yesterday night I almost didn't sleep trying to build something with it, and so that's kind of what I like to do, right? You have like this amazing research of people that spend years in a lab. Is now it's like okay, now what can we do with it, right? And yeah, that's kind of my an example of why I like this like intersection.
Well, I want to. I would like you to share what you were doing with this new model that you said came out yesterday. But just one comment. Well, if you don't mind sharing, of course.
Yeah.
And just one comments on that is that I like once you started explaining what an embedding was, I remember that I did learn about that like some weeks ago. But it's very interesting to learn about how that works because it starts to make sense for someone like who tries to think about how a computer learns the meaning of words. It's like, oh, okay, yeah. In the end, it's just like numbers assigned to thing, which gives them like a value, right? And in that way, like you have value that the computer can understand and which it can use like to work with and to combine with other things and to relate it to other things. Um, and yeah, I mean that's just something very interesting and something that I like, which helps I like to understand since it helps you to make sense out of how this technology is working, right? But yeah, what were you doing with this, if you don't mind sharing?
Yeah, of course. So um, essentially, I just wanted to take the data um, and build anything with it. So just figure out as I build it. And the idea is that if you take with this technology, you take any point on Earth, and it gets you a vector, right? And then you compare that vector with other vectors, and you see similar places, right?
Mhm.
So an idea that came by is if, for example, you're in agriculture and you um, know that in this specific ecosystem, when you plant wheat, it grows amazingly well. Um, so you take the vector of the area where you plant wheat and it works, and you see all other similar areas in the world where you could have that kind of performance, right? And obviously it depends on things like soil, but
Mhm.
so that's an example of a use case of what I'm building. So essentially what I'm building, I'll show you a little demo right now. It's not done yet
Sure.
since the paper came out yesterday. It's still a bit rough, but yeah, essentially the idea is that you take any place in the world, you click on it, it does a vector search on like all other places in the world, and it shows you like the similar place
Mm.
between uh,
Hmm.
a certain radius of distance. So can I share my screen over here?
Sure. I think it's enabled, but you just gotta
Okay.
click on it. Yeah, great.
Okay.
I hope this is being recorded for people watching on YouTube.
Okay. Can you see it? Uh,
Yep. Hmm.
okay. So essentially, um, there are like two technologies that I'm using here mainly. One is this Google data set that has a lot of vectors. Thing is that, it has one vector, which is in dimension 64, essentially 64 like numbers in the in the embedding.
Hmm.
And you have one of these every 10 by 10 meters. So in total, you have like
Hmm.
1.4 trillion, right? So you obviously cannot make like real time computations on all of those vectors. It's like a lot of data. But you
Hmm.
don't actually need, right, this level of precision of 10 by 10 meter. So what I
Hmm.
did essentially is I took this other technology that was developed by Uber, which is called H3, which I
Hmm.
don't even call it technology. It's just like a standard way of dividing the Earth. And essentially, they took the entire Earth and they divided um, into hexagons. So, like,
Hmm.
if you see like this hexagon, is the same hexagon that the Uber app will use, right? Because
Hmm.
yeah, essentially each hexagon has an ID. And what I did is I took a certain resolution of these hexagons and I computed so I found the embeddings for that area, right? And I calculated an average.
Hmm.
That way you don't care really about the 10 by 10, but this one is like 400 meters across, right? So it's like
Hmm.
more interesting and you have less data to work with and you can actually do stuff. So
Hmm.
yeah,
Hmm.
that's essentially the underlying technology, and the idea is that okay, like you go to, I don't know, oh, here I kind of showed what's going on, but let's go to Ecuador, and let's
Hmm.
say I don't know where this is, but you click on it, and it looks for similar places, and like
Hmm.
yeah, it shows you. Now, obviously, this it's not calculating the real thing. It's just the display. I just need to connect it, but it actually works quite well. So yeah, that's kind of the product. So
Hmm. Hmm.
yeah, the idea is that I don't know if you're a researcher and you perhaps have uh, 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 yeah, research on in a certain area of the world, and you want to see okay, which similar places, where can I look that they have similar conditions and that perhaps they're doing interesting research. You can just like go find your research spot, you click on it, and then you find like all of these other places in the world where they have like this
Mhm.
um
Mhm.
similar conditions. So yeah, that's what I built yesterday night. I'm gonna continue today, but that's it.
That's great. It's very interesting. You mentioned that you took an average of the like of all the squares of 10 meters like to create the full 400 meters. Does that work? Like, do you create an average for each dimension of the embedding, or how does it work with that?
Yeah, essentially, what I did is, yeah, you have like two embeddings, and you see it's essentially a list of numbers. And for each number, you just calculate the average. It's not necessarily like the best technique. There are probably like much more advanced or accurate, but it works because you kind of um, keep the meaning of the embedding, and yeah, like it's a way to avoid handling a trillion embeddings.
Mm-hmm. Sure, sure. No, yeah, and just like to make sense about this for people listening who are still listening to this part, which is not, which is a little more technical. But what is very interesting is that like this can actually be used for like statisticians. Is that a word? I think it is. Yeah, for people in statistics or for people in business analysis who want to help, as we were saying, business, agriculture business, or yeah, companies like that, and that can be used for that or for governments or investigation or different things, which is great. How did you build this? Like, were you coding this on your own and connected it with an API to the Google's model, or how was that process?
So essentially, I just took the data set from Google. So they give you the data set with a trillion embeddings.
Mm-hmm.
And essentially the kind of, yeah, relatively hard part was, yeah, to take these embeddings and make it match with the H3 hexagons. So that's
Mm-hmm.
why I had some internet problems before. Essentially, I was getting all of this data. It was like filling in every rectangle, and it's a lot of.
Mm-hmm.
Yeah, I think that I might have to change the resolution of the hexagons, because essentially you have like if you take hexagon of resolution 0, you have like four big hexagons on the Earth, and then you divide it by 7 every time, right? So right now I'm using
Mm-hmm.
resolution 8, which
Mm-hmm.
is, yeah, mentioned 400 meters, but you can take bigger ones, and it means you have to
Mm-hmm.
compute less data, because you don't actually need to take like every single point inside of the hexagon. I just take an arbitrary number, and kind of average it out. So my goal right now is,
Mm-hmm.
is not really to have the most accurate thing. Um, I just want to see what can be done and have a like a working proof of concept. Because as I mentioned, there are
Mm-hmm.
so many things you can do with this. So I just want to like put it out there and see what kind of ideas come. So yeah,
Mm-hmm.
and
What No, 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 what was, well, two things here. Did you? I guess that you created a code that automated this part of creating like the hexagons with the information from the embeddings, right? Because it's a lot of information for you to manually like
yeah.
type.
Mhm.
Um, and then what? And this is, I think, the more valuable part or more practical part for people listening. What was needed for you to be able to create this, as in knowledge and skills?
Um, so this actually, in terms of knowledge, I think the only real knowledge that you need to have to make this or to understand this is to understand what an embedding is, and what an embedding means for these like geographical data, right? Because essentially what they did is they take the data for an entire year and they put it into an embedding. So
Mm-hmm.
if you understand that, then you can uh, figure out everything else, because it's not necessarily complicated technology or algorithms or anything like that. So essentially, it looks cool, but it's a visualization library called TechGL, the one I use for the map and hexagons and the arcs. So yeah, it looks cool, but it's mostly a library. Um, and the other part of knowledge that it came actually as a coincidence is, this H3 standard, because last weekend I
Mm-hmm.
went to a hackathon, um, and
Mm-hmm.
I worked with a guy who was like the expert of GIS, of geographical information systems, and we built a tool that would allow you to. It was quite similar, and it came as a great coincidence that this paper came out this week because I learned so much
Mm-hmm.
that during that weekend. We built a tool that will allow you to pick like the best data center location based on certain parameters. Right. So what we did was essentially the same. We took we did it just for France because there was like a lot of data. Um, we divided France into a bunch of hexagons, and for each hexagon, we filled it with relevant data. Right. For example, the temperature, the internet speed, the I don't remember what other things we look for: electricity price, the connection to the electrical grid, things like that.
Mm-hmm.
So essentially, you had like this LLM that would talk to you and would say, okay, what do you need for your data center? Do you need like cheap electricity? So you would go and tell him, hey, I really care about internet speed. Uh, I don't really mind about electricity because I will have my own generators or things like that. And it will actually go and find the optimal place for a data center. So the data center is like one example, but you can do this for pretty much anything. So that's
Mm-hmm.
where I learned about H3. And I essentially built roughly in terms of architecture the same system that I built that weekend. So yeah, in terms of technology, programming languages, what I used is Python and then TypeScript for the web part, and then that's it. React, uh, but you don't really need React. So I don't know. If you use ChatGPT, there's really little you need to actually know. I think that the knowledge is most in terms of architecture, because especially when you're working with something new, ChatGPT or Claude or whatever LLM you use tend to make mistakes. Um,
Mm-hmm.
and as long as you're like reading what the model writes and trying to understand, I think you'll be good, right? Because if I tried to build this and I didn't know what an embedding was or what it meant, then ChatGPT would have gone and built like random stuff. Um,
Mm-hmm.
so yeah, it's important to have like this knowledge to kind of ground a model.
Yeah, which is what we were discussing, or like this idea that we were like bouncing off, which is like knowing the basic theoretical and technical part to be able like to use either technologies like LLMs that use that for you, or to have people who are like doing the whole actual engineering part of it, right? And then to be able to understand what is happening and how to correct it, to be able to have it be applied. One more question on this technical example before we start going back to like your path and how that all has been. But how do you connect, or yeah, for this, for example, you have like the for the hexagon in for the France hexagons you mentioned. Do you like have the database and upload that to an existing LLM, or yeah, how do you make that, how do you connect those two so that it is practical for people to use? Like the example that you were mentioning of
Right.
someone wanting fast internet. Yeah, how's that?
So in this particular case, the LLM was, I'm not gonna lie, it was kind of useless. So
Mm.
essentially, what we had is this database that for each hexagon, subdivision of France, it had a bunch of data, right? So it knows that in this hexagon, you have this internet speed, you have this cost for electricity, you have this many grid connections. Um, and essentially, what the model did was try to figure out the importance or the weight that we would give to each category, right? So you have for each category, you have an ideal value, right? So fast internet speed, low cost of electricity, right? So if you want to find the ideal data center spot in France, you would take the one that has, fast internet speed, low temperatures, and a bunch of things like that. But what this model did was try to essentially tweak the weight of each category. So it would talk to the human, and the human would say, "Hey, I care about this. I don't mind about this." And then certain categories would have different weights, and you would get different results, right? So for your optimal location, if you don't care about temperature, for example, then you would get perhaps somewhere in the south of France. But if you do care about temperature, then you would get something in the north, for example.
Okay. So yeah, so it was more for um, like tailoring how that information would be arranged, and like how that would be prioritized in terms of the needs of the user, right?
Exactly. Because we would give for each hexagon we would calculate a score, right? So the score, as I mentioned, if you have fast internet speed, the score would go up, right? And we would have like kind of this normalized way to calculate a score, right? So you have like the normalized internet speed times the weight of the internet speed. So if someone tells you, "Hey, I really care about fast internet speed," then the weight will be higher. And if someone tells you, "Hey, I don't care about internet speed," the weight would be lower. And what we did is we have the normalized category times the weight, and we just add that up to build the score. And that's how we rank different locations for data centers.
Okay, good. Yeah, it's just interesting to know, and for people who are interested in the technical side, for them to be able to like learn a new thing about this. Now, getting back into your story more than on the technical side, what? So, like from what you have shared, it sounds like many of the things that you have learned have come from like the experience that you have had, because like you have these tournament which you lost because you didn't know how to code, and so that led you like to want to learn how to code. And then you also have exposure to technicians like scientists who were doing all the research, and also through these projects that you have had, you have learned different like small technical skills that have helped you with that. How much of what you know, and more importantly, how much of what you use for your current job and for the AI agency, how much of that has been a product of learning through like the traditional academic way of learning, so like school and university and all of that, and maybe courses as well and certifications, and how much of that has been like self-taught and like project driven?
I think that, yeah, definitely most what I know right now has been through project or practical applications. If I had to give it a number, I would say 90% is project based, action based, and just 10% is through not even university. University would be like 5%, even less.
Uh-huh.
But yeah, through like a course, for example. I think that a course is so. For example, imagine that you want to understand this alpha Earth model, right? So you have a bunch of things that you need to know. You need to know what a transformer is, what an embedding is. You need to know about satellite information, a lot. So you can go and do a course on each thing, right? And that would be a way to go about it. You can take a university class about satellites. I don't know, but for me, for my type of learning, I learn much faster and I enjoy it to learn by doing. So you have this concept among programmers, which is called like tutorial hell. And essentially it's like when you're beginning, you're like, okay, I don't have the skills to go and build something. So I just watch tutorials. So you watch a tutorial, you kind of reproduce it, and then when you have to build something for yourself, you don't know anything because you just copied. And I think
Mhm.
that the only way to get out of this tutorial hell is just to go and build something. And you really learn so much more when you have a project that interests you. Um,
Mhm.
I think that right now, if I wanted to learn a new programming language, I would spend at most 20 minutes of my time watching courses or reading documentation, and all the rest just building and try to figure out, like, hey, I want to build this. It would be cool to have this. So I go and build it using that technology, using that language. So I think, at least for me, it's really like over 90% has been through practical experience.
Mm. This leads me to like the other question that I wanted to ask you. Like, what would you suggest for someone to build like their learning roadmap? I guess in this case, it's specific for software engineering and computer science, not necessarily for other topics. But I guess that it can be like extended some other things. Like if someone wants to learn music, they might take this framework and use it for that, or things in along those lines. But what would you suggest for someone trying to like develop their own learning roadmap? Because what I think is that sometimes, like in my case, for example, I enjoy a lot like learning about physics and about physics applications. The things that I don't have like any project right now or in the near future in which I will be using physics, to be honest. Like that might come in many years, like maybe for robotics or things like that. And I mean, even though I enjoy learning about those, it's not necessarily something that I want to learn on my own right now, since it will be mostly theoretical. I don't have like a very practical way to learn about that. In the past, maybe in school, through projects in school or like lab experiments or things like that, I did learn through the actual experience. Or in my case, we did. So I was studying the IB diploma, the International Baccalaureate, and for the extended essay, which is like big, the big essay that you need to write to like graduate from that. I did an essay on physics, on like the Bernoulli effect, which is like the relationship between how fast a fluid goes and the pressure in it, right? But I mean, I learned a lot about that through that experiment, although it was just like an experiment in which I learned it. It wasn't really something that led me to create anything with that. So in that sense, like physics right now, even though it's a topic that interests me, is not something very practical. But when talking about software engineering or computer science or coding, I am a lot more into that right now, since some of my projects are related to those things. And so I want to get more into the technical side of things. So for example, I have seen a lot about React, that is like important to know the basics of that. But I haven't like developed a plan for that yet. So for things like these, or for people like me who are looking to create like a learning roadmap to learn through experience and application, what would be your suggestions? Or do you even suggest to build a roadmap, or just like learn as a project keeps evolving?
That's a good question. I think, the way I think everyone has their own way of learning, and what has worked for me is, yeah, just to think about possible project. And you have like all of these, you can call it like basic projects that everyone does, when they're starting out, like a calculator or a weather app. That I have built them. Like, it's just the thing that you do. So I really would recommend like not doing that, because when you do that, you usually watch a tutorial that tells you exactly how
Mhm.
to do it. And when you're stuck, you don't go and figure it out. You just like see how it's done on the tutorial. So I think one of the most important steps of learning is struggling. You know, when you're blocked and you need to figure something out, that's when you really learn. So right now, I was, for example, in your situation, and I wanted to learn, let's say, React, or learn about a transformer models or embeddings. What I would do is I would literally just go to ChatGPT or to Claude. I tend to prefer Claude. Um,
Mhm.
and I would say, hey, I want to learn about this technology, and I want to build a project that interests me. Um,
Mhm.
so let's figure out a project, like a hackathon project, that will use these technologies, and that I will end up with something that I can actually use. And
Mhm.
I think that's kind of the way I would approach it, because it, at least for me, it's perfect because I really enjoy thinking about possible ideas of what I can build, uh, and then I really like building stuff. So that's the way like I would approach it, and really try to build something that you want. So that will not only be useful, but it will actually motivate you to get it done.
Mhm. Mhm. Cool. Yeah, it makes sense because this way you can kind of minimize the topic that you're wanting to learn into something very practical. So let's say right now, as I told you, I'm building a travel app for a client, right? And there are like different features that involve different um, automations that need to be built. Like for example, on part for image generation and things like that. Instead of trying to create everything at once, it would be better to just dedicate like one day to learning the basics of how images are generated through AI and to create a mini project for that that can be created within a day. And that's a way for me to minimize that learning and to stack that up to then build the major project. And I think that that works. Again, talking about music, I'm thinking that maybe someone who already knows the basics of how to play guitar or anything like that can just say like, okay, today I'm gonna learn this song and I'm gonna practice that and I'm gonna maybe add some tweaks to it so that I have like my creative side applied to it, right? So it can apply to a lot of things. People wanting to learn about graphic design, or people wanting to learn about video editing, or even people just doing sports, right? Like people playing football, trying to learn a new skill or things like that. I think that's a good way to minimize that learning into something practical that can be stacked. So thanks for sharing that. Now just two more things that I want to dive into before going into the last three questions that I ask all of my guests. And the first one is, what are your thoughts on vibe coding through with AI, which is something that has become more popular over the last weeks and months?
I think that vibe coding, I don't like the term at all, vibe coding.
Uh-huh.
Uh,
Mm-hmm.
if I think about vibe coding, what I imagine is someone just telling the AI to do something, and I just go grab a coffee and then come back, and I hope it works. Right. So that's
Uh-huh.
kind of what I imagine when I hear vibe coding.
Mm-hmm.
Um, so I don't really like the term, but I think that using AI to code, to write code, to learn code, to do anything is not only useful but necessary right now.
Mm-hmm.
For the project that I just showed you, I think that what 80% of the code, perhaps even more, it's written by AI. Um,
Mm-hmm.
I think I this would have taken me much longer. Like I did it yesterday in a couple hours, and yeah. So I think that in this world right now, you cannot survive if you don't use AI, unless like you're a very specific topic or
Mm-hmm.
something like that.
Mm-hmm.
So yeah, I think in that sense, vibe coding is necessary. Um, I
Mm-hmm.
also think that it's important to learn not necessarily the technology, but the foundations or the principles.
Mm-hmm.
Because right now, a lot of people do vibe coding in the, I don't want to say the wrong way, but it's kind of yes, like in the way that, yeah, they just tell the AI to do something and hope it's right. So
Mm-hmm.
you have a lot of apps out there that have huge security vulnerabilities, or that end up, having a bunch of errors. So I think that vibe coding, if you want to build something small like a prototype or something fast, it's good.
Mm-hmm.
But the moment where you want to build something bigger, something um, that actually like
More complex. Mm-hmm.
yeah, more complex, then you actually need to give it some thought. You need to sit there. You need to plan. You need to think. And so if you want to become a developer that heavily uses I would focus not on learning the technologies, the frameworks, libraries like React, for example, but I would learn the underlying aspects, like how a browser works, what the DOM is, or um, certain security principles, like what
Sure.
you need to have on the client side, what needs to be on the server side, because that's like a classic mistake that, you know, I would say is at fault of most vulnerabilities right now in vibe coded apps. So kind of try to learn foundations and just not necessarily the basics, but the foundations of each thing that you want to do.
Sure. No, and it makes sense to learn. Like again, right now we're talking about software engineering specifically, but like as AI keeps evolving, this will apply to other areas that are automated, right? Like right now, software engineering is one of the areas that is being automated the most, but this will keep extending to other areas. But it is still important to know like the foundational non-tech knowledge from which the actual tech stems from, right? As you were saying, like that is a perfect example. Like the security part of an app is like you gotta know how that works, how that is built, and then I mean that gives you enough context to understand what the AI is doing and what it might be missing. Because I think that's the problem with this. Like it's not necessarily that it doesn't create things; it's that it misses some things when it is creating that. For example, like the security part, as you were just saying. Um, one other thing about this is what are your thoughts on like the importance of learning coding, since like maybe 3 or 5 years ago people still keep saying like no, the one of the best things you can do is learn Python or learn to code and to become a computer science pro or like things like that, whereas today it's just like you gotta maybe keep doing the thing that you're doing and try to integrate that computer science part through AI. What are your thoughts on that?
So I still think that code is one of the highest leverage skills that you can have. Um, it's just that the barrier of entry is much lower. Like right now,
Mm.
you can build things that would have taken like perhaps a senior engineer or something like that. Weeks, you can do it in days, even if you don't know. And obviously, the quality won't be the same, but functionality wise, you can. Um,
Mhm.
and I would still recommend to learn code, but as I mentioned, not like you need to you don't need to memorize the different functions. You need to understand the foundations. And
Mhm.
if you know that, then the AI will be smart enough to handle everything else. And eventually, the AI will be smart enough to handle pretty much everything. And that's like another conversation because I think that, yeah, there will be a point where AI will handle everything pretty much perfectly. And in that situation, I think that I would tend to agree with you in the sense that, okay, it's much more important to learn if you want, like if your passion is, I don't know, birds, for example, okay, you go and you learn birds and then you use this AI that will be able to do everything for for like your passion.
Mhm.
Um,
Mhm.
but yeah, I think that code right now is still one of the highest leverage skills you can have, and it will still be um, for years to come.
Mm. And this leads me to the last question about all of these topics that we have been discussing before getting into the last three questions that I usually ask. Um, and yeah, with this is like, how are you personally preparing for the changes that are happening and for the changes that will keep coming? Because I guess that like in your first years it was mostly about okay, I'll learn to code. Right now it's like okay, I'll learn about AI and how to use AI. How are you managing and approaching that?
Right. So I think that this is like a recurring topic between computer science students. Like
Mm.
some are like very afraid. They say, "Okay, I'll be like out of a job." Um, I personally am rather excited about the changes.
Hmm.
I like coding, I enjoy coding, but my passion is not coding. My passion is building stuff. Um, I like to think that if I was born 200 years ago, I wouldn't have been a programmer, obviously, but I would have ended up, building stuff, whether it was like a
Hmm.
carpenter or something else. Like that's what really motivates me. Like the just the concept of being able to say, "Oh, I thought of this. This would be cool," and just go and build it. I think that's what I love. Um,
Hmm.
so what AI gives me, sure, it takes away code, but code is a tool, and it gives me the possibility of doing what I want much faster and potentially much better. So I'm honestly excited for that. And I think that the way I'm preparing for that point where I probably won't have to write a single line of code is to kind of focus on the other areas. Right now, assuming I can build anything like with just a single prompt and it reads my mind and it does it perfectly, the issue becomes selling, becomes marketing, becomes okay, like how do I actually make something people want to use and how do I put it
Hmm.
out there? So
Hmm.
I'm not really 100% focused on that part, but I'm learning about it, especially
Hmm.
um, through Scalesia because you know even if Jose is the one that handles sales, I handle tech. Um, there is a lot of intersections, and I am learning a lot about sales just for being in this business. I'm learning a lot about marketing, even if I'm not the one recording the ads or going out and calling people. I'm still learning a lot, and I think that's very valuable. I think it's Naval Ravikant that said that the two biggest skills are building and selling. And if you
Hmm.
can do both, then you can rule the world essentially. And I agree with him.
Hmm. Sure. No, yeah, I resonate with you in the part of like being someone who has ideas and just wants to be able to build them, right? And it's funny because ever since I was young, I was like imagining things like this, not necessarily doing things like this, but when I was a kid, I was just like imagining. So I went to Six Flags, for example, and I was like, oh, okay, I want to build like a roller coaster park or whatever, and I would just sketch in a piece of paper and draw like the roller coasters and things like that. And so by the time those were like dreams and things that I wanted to do, but eventually, as I started doing things mostly online, that started becoming like a way for me to be able to gather the tools, right? To be able to build the things. And so right now, if I'm like, oh, okay, I want to build a small business on selling like mugs for coffee or anything like that, I have like the skills and the knowledge to be able to do something like that. But of course, I want to keep like doing more complex things. And regarding what you said about building things that people want, I think that I saw one interview done to Sam Altman, and he was saying that like in the future, one of the most important things will be like just to be able to spot problems that people have and to build, not to build, but like to know what people want to have solved or what they want in general, and having that be a and having that as a very valuable skill, since you will have like the tools to build that almost like automatically. Of course, right now we're not at that point yet, but we might eventually get to a point where that is possible, right? Like just spotting a problem or a need and then covering that for people who actually have that problem. So yeah, thanks for sharing that. Now I want to get into the last three questions I usually ask, and you can answer them any way that you want. They can be related to any of the things that we have discussed or not, and to something like completely different. So the first one is, what is a book, movie, a music album, a vlog, whatever, that you have watched or consumed recently that you enjoyed or found valuable?
There's actually this one that I was just reading before the this call, and it's probably one of the few books that I've went over few times, and it's
Mm-hmm.
yeah, the like
Mm-hmm.
the almanac of
Yeah.
Naval Ravikant. I
Mm-hmm.
I think that Naval is yeah, like, I'm quite inspired by him, by his philosophy, um, because he's not one of those, or at least from my perspective, I don't tend to um, have idols, and I wouldn't say like Naval is my idol, but I do admire him, especially
Mm-hmm.
because I think that he has a certain balance between um, or that he has figured out what he wants in life, right? Because you have like two extremes usually. You have like the kind of entrepreneurs that say, okay, just money, 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 and work, and that's all that matters. And then you have the people that say, no, like money doesn't matter at all. I just want to live on the beach somewhere.
Mm-hmm.
Um, and I think that same as with like research and applications, I tend to be more in the middle of a lot of subjects.
Mm-hmm.
Um, so yeah, I think that he has found a good balance between happiness, success, and doing what he really wants. So uh,
Mm-hmm.
that's I think the closest so far that I've gotten to seeing someone that is in a place where I would really want to be. So yeah,
Mm-hmm.
uh, that's the book I would recommend.
Great. This second question might relate to what you have learned about Naval, or maybe to something else. But what is something that you have recently learned or discovered that you found valuable or interesting?
I think, well, if you would have asked me that question before, I would definitely have said this Alpha Earth thing. I think it's
Uh-huh.
just crazy. I think I'm fascinated by it, and I definitely want to keep building stuff on top of it. As I mentioned,
Mm-hmm.
the paper came out yesterday, so the opportunity to become like an expert in this technology is there, and
Mm-hmm.
um, yeah, so that would be something. I think we have already talked about that a lot. Um, what else can I say? Um, no, I think that that's really what comes to mind. Like,
Mm-hmm.
ever since I saw the paper, that's like the only thing that has been on my mind almost. And
Mm-hmm.
perhaps just to add a bit to that, I think that yeah, like every once in a while you see a technology and you say like, wow, like this is crazy.
Mm-hmm.
And it happened with I didn't think I mentioned it, but I was actually one of the beta testers for GPT. So before ChatGPT came out, I was like, I saw this video of it was like this interface where you just enter text and it would like autocomplete. I was like, wow, this is
Mm-hmm.
crazy. It was so dumb.
Mm-hmm.
It was so dumb. Like it could barely make a sum, but I was
Mm-hmm.
fascinated by this technology and I actually started learning. And that's kind of what allowed me to be in certain roles over time that I really like. I saw this technology and I learned about it and I started um, making applications, right? I didn't become an expert in transformers or like the underlying technology of ChatGPT, but I would like to say that I kind of went and built stuff with it, and that's what got me
Mm-hmm.
like, one of my roles at startups, and yeah. So I think that whenever you see something like that really excites you and interests you, you should go for it and learn. I think right now we're at an age where we can really take the risk. So if you
Mm-hmm.
are 40 years old and you've made your career in something, it's much harder to make the switch, right? So right now it's the best time there is to just explore different fields, different technologies, different anything.
Sure. No, and with this one extra question that is that I wanted to ask earlier and that I didn't is, given your experience being a founding engineer at a startup, what would you say? Yeah, what's your advice for anyone wanting to go through that path?
Um, that's a good question. I think I was founding engineer at two different startups, and they were two vastly different experiences. I
Mhm.
think that I really enjoy that role because, as I mentioned, what I like is to build, right?
Mhm.
At that point, you're in a role where you get a lot of liberty. Depending if you have like a technical CTO, it really depends on the startup, but essentially you get the liberty to choose how you want to build something, right? And you get a lot of leverage, but also a lot of
Mhm.
responsibility. Um, and yeah, I think that's what I like. Just to be able to go and choose how to build something. So if you want to become a founding engineer uh, at a startup, I think it's a very different skill set than if you want to work at Google, for example, right? If you want to work at Google, you usually learn foundations, you grind a lot of lead code. But if you want to be a founding engineer, you need to be able to produce, right? You need to be able to say, hey, I want to build this and go and build it, right? So
Mhm.
I think that you need to have like not actual skills, because the lead code is also like a interesting skill, and it's quite hard, but yeah, but you need to actually be able to produce something and do it fast and do it well, because if you're not able to, then startup will most likely fail, right? So I don't know,
Mhm.
that's the way I see it.
Mhm.
So if you want to be a founding engineer, just go and build and build and build until you get good at it, and then you can um, do it for a startup.
Cool. Yes, it sounds good. And I think that also has to do with this part of like taking having initiative, right? And just like not waiting for you to be told about doing something, but really just having an idea and doing it, which is good and which is also fun, of course. And then well, thanks for that. And then the last thing is my podcast is called Coffee Lounge, and I'd like to ask my guests what their favorite kind of coffee is. That can be a coffee bean or a specific coffee drink. And what is your favorite situation for drinking coffee, or maybe a specific place in which you love drinking coffee?
It's an interesting.
If you do like coffee.
Yeah, no, I love coffee. Um,
Mhm.
so if you would have asked me that question perhaps a year ago, my answer would have been drastically different. Um, I was the kind of person that would be able to drink any kind of coffee and just wouldn't mind. Um, and actually, I didn't like those kind of specialty coffees that, uh,
Mhm.
or anything like that. But over the past year, I found like my favorite spot to work in Paris, because usually you get the cafes that become like very crowded, and then you get the library where you just can't order food, or the like. So I found this coffee, which is perfect. It's not crowded. Um, it has good food, and they serve kind of specialty coffee. So I drank that a lot, um, and I developed a taste for it. And now it's kind of a problem, because I don't I know the bad coffee that I used to like. Um,
Mhm.
so I wouldn't say that I know a lot about coffee, but now I do enjoy the expensive coffee, which is a problem. And yeah, so to answer your question, what is my favorite kind of coffee? Um, Not sure. Um, I think that the one I tend to order there is kind of Arabica. Um,
Mhm.
I tend to prefer lighter roasts. I would say like medium, perhaps slightly less, depends. And that's all I can tell you. I don't know how to describe coffee tastes.
Cool. Yeah, no problem. Well, yeah, no, it sounds good. I also enjoy like smaller coffee shops that have great coffee. And I mean, here in Mexico City, we have a lot of those, so it's great. And I mean, in Europe overall, in major cities, you I guess all around the world, but like in major cities, you can always find places like this. So yeah, thanks for sharing. How's that place called? The one you go to?
Um, oh, it's called Malongo, which it's like a famous coffee brand, but like in this particular store, they serve. They have like, yeah, baristas. that get like a different kind of coffee that you can buy um,
Mm,
online. I think. So yeah, it's yeah. And what about you? What's
cool.
your favorite kind of
No,
coffee?
yeah, just so that if I have been getting used to ordering flat whites a lot, so I really like having that slight taste of milk. Because I mean, I don't really like milk. I don't at any time like just have a glass of milk and drink it. Um, so in coffee, I like to taste the coffee, not necessarily the milk, but that's a good way to have a slight taste of milk. And yeah, I mean, I enjoy that drink a lot, and I do like specialty coffee shops since I like it's usually in those that I can order like a proper flat white that is actually properly done. Because sometimes in other coffee shops, when I order that, they just bring like coffee with milk, which for some people who don't like coffee a lot, they might say like that's what you're ordering, but no, it's not the same. But yeah, that's the one that I like. So yeah, no, thanks for asking. You're the second guest I think that asks me about that. And yeah, thanks for coming. I appreciate the conversation. I appreciate your time. Is there anything else you want to talk about, mention, question,
Yes,
anything?
so I think that actually I answered your question wrong because I didn't tell you what kind of coffee I order. Uh, so I actually order Americano, like no sugar, no nothing. Um,
Mm.
yeah, so that's that's what I like. So something else to add. Um, Not really. I enjoyed the conversation. I'm glad we could make this happen. I think that you ask good questions, and yeah, let's definitely keep in touch. Um,
Sure.
there, I think that you probably have some very interesting background, and I'd like to learn more about that. Perhaps the podcast is not the best way to do it, but yeah, let's keep in touch. And thank you for your time for having me here.
Sure, yeah. Well, thanks for coming.